So now what we do is we start practicing the previous year questions from medical entrance, from the JEE and from the JEE advanced. So what I suggest is those people who are new here, please make sure that you go through the previous videos, because those videos are the one which gives you foundation for the practice of these questions. But it doesn't mean that I'll be skipping the steps here, or if I'm not detailing the steps here, I'll be doing the same as in previous videos. But it is highly recommended that you go through the previous videos and then only come back here, because see, that's how the structure of the playlist is designed. It is designed from A to Z. You start from A, you sequentially move to the higher level steps, and then yes, the moment you complete the watching the playlist, the entire playlist, yes, the chapter is complete. It covers almost every aspect from the NCRT. So once again, highly recommended that you go through the previous videos. I think there are 120 to 150 questions being solved. If you solve those questions, then you'll have a concrete foundation about how to solve the upcoming previous year questions. Okay. All right. Now coming to this question. So it says a particle moves in a straight line so that its displacement x is given by x square is equal to t square plus 1. Its acceleration in meter per second square is. It's a very tricky question. It's a very lengthy question. In fact, I would say. See, let's try to understand and solve this question. So what is given is x square is equal to t square plus 1. Okay. Before I take you to the solution, let me clarify a couple of doubts that students much often ask. Shouldn't be a problem for the engineering aspirants, but for the NEET aspirants who focus more on bio and chemistry, unlike engineering where they give more emphasis on maths. So for people who want to understand this concept very clearly, it's very simple. Don't go beyond this. See, it's d by dt of t square is 2t. Okay. I'll add one more example. D by dt of t cube is 3 into t square. But at the very same time, d by dt of x square, if x is not a constant, I repeat, if x is not a constant, is equal to 2x into dx by dt. Again, if x is not a constant, d by dt of x cube is equal to 3x square into dx by dt. Simple. Let's go through that again. So d by dt of t square is 2t. At the same time, d by dt of x square is 2x into dx by dt. D by dt of t cube is 3t square, but d by dt of x cube is 3x square into dx by dt. In which case, if I mark this given equation as equation 1, and if I differentiate with respect to t. Okay, now you may ask me, why do I differentiate with respect to t? See, because if I'm given x, if I differentiate it with respect to time, what do I get? Velocity. If I'm given v, velocity, if I differentiate with respect to time, what do I get? Acceleration. What is being asked in the question is to find out the acceleration. All right. So we'll differentiate this equation. Now, when we differentiate with this equation, we get d by dt of x square is equal to d by dt of t square plus 1. So d by dt of x square is equal to d by dt of t square plus 1. Now have a look at here. It is not d by dx of x square. It is d by dt of x square. In which case, what is d by dt of x square? Is it 2x? No, it is 2x into dx by dt, which is further equal to d by dt of t square plus d by dt of 1. Now, what is d by dt of 2x into dx by dt? See, dx by dt is velocity, so this is 2x into v is equal to, what is d by dt of t square? Is it 2t into dt by dt? No, d by dt of t square is 2t plus derivative of a constant is 0. So we have 2vx is equal to 2t, or we can say xv is equal to t. From which we can write that Okay, so we have xv is equal to t. Let me mark this as equation number 2. Now here you need to understand that both x and v are function of t, which means we have two functions here. How do you differentiate that? Very basic. So d by dt of, say, now let me put this as simple as possible. One function into other function is equal to 1 into derivative of other function plus second into derivative of first function. Simple. So d by dt of first function into second function is equal to first into derivative of second function plus second into derivative of first function. Okay. What is the first function here? X. What is the second function here? V. So if we differentiate this given equation, we get d by dt of x into v is equal to d by dt of t. Now you might be thinking, won't there be a shortcut method to solve this question? We'll discuss upon that too. But as of now, let's focus on the primary method to do this. So what you get is first into derivative of second function, which is v, plus what is the second function? Second function is v into derivative of first function, means into d by dt of x is equal to, what is d by dt of t? It is 1. Now x into, what is dv by dt? dv by dt is rate of change of velocity with respect to time, which is acceleration. So this becomes acceleration plus v into, what is dx by dt? dx by dt is rate of change of displacement, which is velocity, which is equal to 1. In which case we can say that xa plus v square is equal to 1, or a is equal to 1 minus v square upon x, which gives our answer. We have found out the expression for acceleration, but are we done with the question? No. Why? Because we may feel that we have found out acceleration, but none of the answers match. Why? Because all the answers either have x or are a combination of time and x. But in this case, we have acceleration expressed in terms of velocity and x, in which case the answer is not complete. And how do we complete this? We need to complete this acceleration by converting v in terms of x. And how do you do that? See, what is equation number, I didn't name this, so let us name this as, okay, some equation. So xv is equal to t implies, what is v is equal to? V will be equal to t by x, right? So I can change this equation here. What do I get? I can write that a is equal to 1 minus, instead of v, what do we have? T by x. 1 minus t by x, the whole square, the whole upon x. So what is a is equal to? A becomes, let me not skip the steps, 1 minus t square by x square, the whole upon x, which means a is equal to x square minus t square by x, the whole upon x. Now, can we make any further changes here? Yes. See, what is given in the question? The question is given that x square is equal to t square plus 1, which means x square minus t square is equal to 1, right? So if I bring this x square minus t square is equal to 1 in this equation, what do I get? I get a is equal to, instead of x square minus t square, where I have can write 1, right? X square minus t square is equal to 1. Yes. And oh, there's a mistake. It's not x, it's x square. So we can write 1 by x square, the whole upon x. So I'll write x as x by 1, right? In which case, what is a by b, the whole upon c by d is equal to a by b into d by c. In this case, it will become a by b, 1 by x square into 1 by x, which is equal to 1 by x cube, right? 1 by x cube. So that gives us the answer to be option A. Now, if you're looking for a shortcut method, you may argue that since it is given x square as t square plus 1, you can write that the okay, so we can write the 2x into v, right? 2x into v is equal to 2t, and then you may say, since velocity is here, the second derivative should have a component of t or maybe a component of a, and then you try to make rough estimates of powers of a and t, which doesn't make sense here. Why? Because x and v are not arbitrary values here. X and v, both of them are functions of time, which means they have to be further differentiated to make sure that no variable or no constant get eliminated. And if such a elimination takes place, it may give us a wrong answer, because there is another option which says t square by x cube. So even if you say that there can be a third power of x, you still have two options, 1 by x cube and t square by x cube. So you can't come into conclusion. So it is always better that you spend some more time in solving the question and not search for shortcut always. But yes, what I always suggest to my students is, don't start solving problems in a in a rush and then say that you are solving problems quickly. No, see, how do you solve problems quickly? It should come through it should come to you automatically. And how does that happen? That happens when you keep on practicing similar questions, and you repeat one question time over and over again. That's how you increase your speed. So things should come to you naturally. Now the same question, when you do it in an exam environment, due to that environment, what happens is a kind of rush, called adrenaline rush, or any kind of instant hormonal actions, which gives you a push to solve these questions in a much faster way. But since I'm explaining, it will definitely take some time to do. And if you come across any methods which can be used to solve these questions, always make sure that those questions don't let you to false eliminations of constants or variables. Having said so, let's move on to the next question.